I'm Yaselin.
I'm Maria.
And I'm Pricilla.
And we're doing the
Rube Goldberg.
We're all in charge of the primary role task and the secondary role task, and we're all supposed to do a self-reflection. I am the designer. I'm going to clearly assemble the instruction and information that are included in the apparatus.
I am one of the presenters. Both Yasin and I are the presenters, and we're going to look at the chemical and physical changes in each step of the process and explain it clearly. We are going to use appropriate and correct scientific vocabulary that is supposed to be used, and we will demonstrate 3 or more rubric Goldberg steps during the apparatus process.
And I'm the reporter and problem solver. For the reporter part, I balance a chemical equation demonstrating understanding of coefficient, subscript, and in a formula. And for the problem solver part, I use stoichiometry to determine mass, volume, equivalence, and number of the molecules, explaining the steps and demonstrating how to solve the problem.
And this is our Rube Goldberg. Bye.
Bye. Hi, my name is Pricilla, and I'm going to show you how to balance a chemical equation. Well, first off, you have to start by adding how many of the elements on each side, and on this side we just have pure ones, and then on this side we have 1, 3, 3, and then 2. Okay, and then what we do with that is we multiply these 2 together, and since it's in the front, you have to do that to each, because that's the whole equation. And now you have to times this by 2. You have to put the 3, and then after that you have hydrogen has 2 on this side, so you multiply by 2, and then it turns into a 6. And then you multiply this side by 3, and then it will be a 3 for hydrogen on this side. And for here, you multiply it by 2, and there'll be 2 in front, and then 2 on this side. And that's how you solve it. That's it, right?
3.
Okay, so what I'm doing here is solving a mixed problem. And we have to find the volume in this, because we already have the N2 in both sides. So we're given 25.0 grams, and we use that N2, and then we divide it. We always have to divide it by grams of N2, and then it's going to be 1 mole. So these 2 cancel each other out. And then after that, we have to, since there's 1 here, we divide it by 1 mole of N2, and there's 2 here, so we divide it by 2 moles of N2. So then after that, we cancel these moles, and then we add the other mole over here of N2. We have divided by that, and then we have the magical number of 22.4 liters of N2H3, and then we cancel these out, and then after that we're left with this. So we have to multiply this all together, and we have that down here. We divide it by 28.02. And it equals 40 liters NH3.
We use the periodic table for nitrogen, and to find the volume, or mole or mass, and we got 14.01. We multiplied 14.01 times 2, and we got 28.02, and we divided that with what was left, and we got 40. I'm going to drop this ball. It's going to roll down. It's going to hit this. When the ball hits this, it's going to cause the dominoes to knock down. The last one is going to slide down. It's going to hit this bouncy ball, and this bouncy ball is going to roll down.
Then it's going to land into this cup, and then the cup will fall down, pulling the string, which is going to let go of the which is going to make the paper clip let go of the piece of tape held onto the car, causing the car to roll down, knock down the metals into the diagonal, causing the reaction. 6.